Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. Hi, everybody. Tonight, I will be going through the review for Quiz 2. And let me remind you, this Thursday at about 8 a.m. or maybe earlier, I will be giving quiz number 2. I like my special effects. Don't answer that question. But anyways, at that time or even a little earlier, I will send out an email with the password to open up quiz number 2 PDF file, which you can find in the assignment area of Blackboard. You'll have until Friday, 8 p.m. to upload, take quiz 2 and upload your answers. This is important as a single PDF file. I reserve the right to subtract up to 25 points for anybody who doesn't follow instructions or anyone who doesn't upload your. Here I have quiz 1 and 2. It should be just quiz 2. I can't change it right now. But anyways, on time. And quiz 2 has 5 pages, 18 problems, including 6 multiple choice, and it's worth 50 points. It will cover chapters 3 and 4, along with temperature conversions. In other words, how to go from Fahrenheit to centigrade and centigrade, or Celsius and Celsius to Fahrenheit, and how to go from Celsius to Kelvin, the 3 different types. And by Sunday or 4 p.m. or earlier, after quiz 2, you take it, I'll have your scores on Blackboard. Also send out individual emails like I did in quiz 1. To do well on quiz 2, watch the videos for the chapters covered and do the practice problems. And the rest, tonight you're here. And one important thing, don't forget, keep up with the videos and don't forget to upload your labs when they're due. One other thing I put out is today at about 3:15 today is an announcement. You all got individual email, and that's for my test anxiety reduction method. I just call it the method. I've tried different names and nothing sticks. So, but anyways, this method eliminates test anxiety. Over the years, I've had a number of students with test anxiety. They'll come to my office hour and whatever, and wow, I know how to do the problems. And I'm thinking this is going to be an A student. They take a test, they barely get a D. What's going on? And they get very anxious. Their brain goes, whatever. I'm a chemist, not a psychologist, psychiatrist. But I came up with this method, and in the video, I'll explain how I came up with it, and it works. And so here's the link to that video to learn how to do it. Once you learn how to do it, it works not only for chemistry, but any other class you take. So I definitely recommend you watching it. If you have trouble mastering this method, ask for help and we'll meet in a private Zoom meeting and I'll help you learn it. It's not that hard. In fact, I think I mentioned it in the video. I'm not sure. A number of years ago, a nurse at my doctor's office learned I'm an award-winning teacher at COD. I am. And said, I'm having a problem with my 10-year-old son. He knows how to do it at home and can't do it at school, his quizzes and all that. So I said, bring him in and I'll teach him the method. She, I can't bring him to here. So I said, let me teach you the method. And then you try teaching it to your son. And it turned out I must have done a good job, and she did too. And she taught her son, and he started getting almost perfect papers on his quizzes and stuff in school. So here's the link to the YouTube for that. All right. Let's go through material on quiz 2. This is found in the lecture, what you'll see on the screen is in the lecture area blackboard, cleverly named Chem 1211 Quizzes 1 and 2 Review. I used to give both of them at the same time. I've now separated them by a week, but I got lazy and I never separated the reviews. Bad, Dr. White. All right, chapter 3. We started getting into chemistry. All right. All right, first thing is chemistry involves studying matter. And the question is, what's matter? And that's anything that has mass, meaning has weight, and occupies space. Now, when we talk about matter, there are three physical states of matter you should know. And there are three physical states of matter you should know. Don't you like when Dr. White's subtle? All right, first one is solid. And you should know a solid has definite shape and definite volume. Next, a liquid, like what's in this bottle, has indefinite shape, but it does have definite volume. And finally, what I'm breathing, and hopefully you are too, the air, that's a gas. And a gas has indefinite shape, indefinite volume. So the three states of matter, physical states of matter, are solid, definite shape, definite volume; liquid, indefinite shape, definite volume; and finally, gas, indefinite shape, indefinite volume. And you should know all that. Now, when we talk about substances, there are two types: an element and a compound. And the elements, and let me hold on while I open it up. And the elements are found in the periodic table. And that's one type of substance, such as copper, silver, gold, uh, oxygen, carbon. Those are all elements. Now, the other is a compound. And a compound is made up of two or more elements. What would be an example of a compound? Well, water is a compound. What's another example? Well, your table salt, which is sodium chloride. I don't know if you saw it in the video, but if you go out with a bunch of chemists like Dr. White, and we're out for breakfast, lunch, or dinner, one of us will invariably say, can you please pass the NaCl, NaCl, salt, NaCl. True story, I've done that too many times. Now you know you're with a chemist. And these are compounds. The oxygen you're breathing now, O2, is a compound. The nitrogen gas that's part of the air you're breathing is a compound. Now, the other thing is a mixture. A mixture is when you take two compounds and mix it together, and both of them retain their chemical identity. An example of a mixture is, and I'm not going to do it, but if I have water, and if I dumped in some salt and shake it up, I'll have a mixture. If I take and put sugar in here, which I don't need because I don't need the extra weight, but shake it up, you'll have a mixture. Let me check one thing here before I move on. No. Now, one thing I don't have here are these. Certain times of mixtures are either homogeneous or heterogeneous. And homogeneous is the same throughout. That means that mixture, everything is the same. You have like air. If I'm right here, there's a certain amount of oxygen and nitrogen. If I go by my door, which you can't see, or outside my house, that air will also have the same mixture of oxygen and nitrogen because it's homogeneous. The other is heterogeneous, and that's not the same throughout the mixture. An example would be if I took this bottle of water, which I won't do, but if I threw in a handful of sand, I shake it up real good, and I just let it sit for a little while, what's going to happen? The sand goes to the bottom and the water will be up here. And it's not the same throughout, and that would be called a heterogeneous mixture. Now, another example of something that's heterogeneous is if you ever look at oil vinaigrette dressing. I make my own, but my mother, when she was alive, her favorite one, let's see if I can get to that. Not that I get any kickback from this company. And if you look at this picture right here, do you see how there's a clear layer at the bottom? And there's even other particulate solids here and a clear layer on top. And there are two separate layers if you forget about the solids. And that is a heterogeneous mixture. So you should know the difference and examples of homogeneous and heterogeneous mixtures. Not that you should try, but if you go to a gas station, the gasoline you put in a car is homogeneous. All right, now, when we talk about chemicals or substances, they undergo different types of changes. One is a physical change, and the other are physical property and a chemical property. And I'll talk about changes in a second. Now, a physical property tells you something about what that material is. Like water at room temperature, like in my office here, is a liquid. If I were to put it in my freezer and come back tomorrow morning, it will turn into a solid. And the temperature at which that does that is a physical property. Another example, my ring is gold. If I go like this, if I had polishing, and it will be shinier. And luster is an example of a physical property of a metal. Now, there are chemical properties, and chemical properties tell you how well or what type of possible chemical changes. Chemical change, you make a new chemical or substance. A chemical property of water is it won't burn, which is why we use it to put out fires. But, and do not try this at home. A piece of paper, the material substance of the paper, which is cellulose mainly, if I put a lighter under here or flame, it's going to burn. Same thing with, I don't have one you can see, but I have a collection of candles that I used to go to the Netherlands, and there was this great shop in Gouda, you know it as Gouda, that had hand-dipped candles, and I have a bunch. They're about this diameter, like, whoa, big. Beautiful. But anyways, the wax or the material the candle is made out of is flammable. It will burn. Now, you should know examples for those. And I talked about this in the videos. Next, we have a physical change and chemical change. And a physical change indicates that something in terms of physical is gone from one state to another. Example would be a physical change. Ice melting. When ice melts, it goes water from a solid to a liquid. When you boil water, it goes from a liquid to a gas. Now, chemical change would be, and now I have to admit this, and I might have admitted it in one of the videos. If you talk to any good synthetic organic chemists, they were all pyromaniacs when they were little kids. They like to burn things. And I have to admit, I did too. Luckily, never in the house. I never burned my parents' house down. But in our backyard and also in the alley behind our house, did a lot of experiments. Don't tell the police. But, anyways, a chemical change would be if you took a piece of paper and lit it on fire, it will change from what it is to something else. If you take gasoline and burn it, don't try this anywhere, it will go from the molecules of the gasoline, mainly octane, to carbon dioxide and water. And that would be a chemical change. Now, to make things interesting, in your stomach, when you eat food, you're breaking it down. And that's a chemical change. Did you know you're a walking chemical plant and chemical reactions are going on throughout your whole body? Yep, including your stomach. That's how you break down proteins, carbohydrates, and fats and oils. And if you take my 12-12, which I don't teach here anymore, but if you take my Chem 170 that I teach at Elgin Community College, one semester organic, you learn those things. Now, one of the important things I've asked you to learn is temperature conversions. And this is going from different scales. Now, for each of these three formulas right here, those will be given to you in important information, quiz number 2 at the back of the quiz. In the past, I'd make students memorize it. And a couple of years ago, I had a faculty member challenge me, and he challenged me and said, when you give tests, are you teaching your testing your students' knowledge of chemistry or their knowledge of chemistry and their memory? And I had to admit, at that time, I was doing their knowledge of chemistry and their memory. He said, well, you shouldn't really do that. And he convinced me. So I've cut down, way down on memorization because you can go to the internet or pick up a book and find these formulas. But anyways, important thing to remember, each of these numbers on the right of the equal sign, 273, 1.8, and 32 are exact numbers. Next, for the last formula, you have to do the subtraction before you do the division. For the last formula, you have to do the subtraction before you do the division. And let me see if I have it open. And I do. oh, maybe 4 or 5 points. Let me make sure you can see what I'm doing. And you can. So as you've learned from my videos, how do you do a problem like this? First thing is you read it and you find out, what are you being asked to find? The temperature in degrees C. And I like putting degrees C like this, a question mark, what I'm trying to find. What are you given? This. Now, from the formulas which you'll be given, degrees C equal degrees Fahrenheit minus 32 divided by 1.8. Hopefully you all know how to use your calculator. By the way, these problems you can do in scientific notation or regular decimal, doesn't matter. So I'm going to now and first I'm going to do the subtraction. And I get 60. And leave that on there. If you have this type of calculator or any on, you can do divide and then 1.8. And my calculator gives me this number. You'll see why I laugh. Actually, mine says 0, 1, but I don't write down the 0 like this. All right. Now, if we look at this, and after your name on quiz 2, it will say, please use proper significant figures for all calculated answers. 32 as part of the definition is an exact number. 1.8 is part of the definition of how you convert from one to the other. That's an exact number. That plays no role in how many significant figures your answer should have. So for this, which is a division, you get the same number of significant figures as the number you're multiplying or dividing by that has the fewest. Well, this has 2 significant figures, 92. And that's the only number you use. So your final answer for this problem should have 2 significant figures. So to round it off, I will keep the 3. That's my 2 significant figures. The next one I use to round off, and I use my double squiggly line, is 3. And when it's 4 or less, you drop that and everything. If it was 5 or more, you drop everything after that, and the number in front increased by 1. But in this case, we'll drop all this. You never change the exponent. So the correct answer here would be 3.3 times 10 to the first degrees C, or 33 degrees C. You could have also written it like this. Either one would be correct. So remember, the numbers in these formulas are exact numbers. And the only thing that plays a role in the significant figures is the temperature that you're starting with. All right, let's really get into chemistry now. And I started in chapter 4, and we talked about the atom. And you should know that the atom is the smallest particle of an element that retains the characteristics, actually all the characteristics of that element. Now, if you've watched my videos, you know when things get really important, I'll draw this, I'll do like this. And now I'm going to be real subtle. typing. Don't you like it when I can be real subtle? Hint, know this. And that's the subatomic particles of, you like when I'm subtle, huh? I found out years ago when I was a student, I couldn't read my instructor's mind. And I found out also when I started teaching, students couldn't read my mind. So that's when I started being subtle. All right, subatomic particles. How many know what a submarine is? Sub, under, marine, water. It's a boat that goes underwater. No, I'm not going to sing Yellow Submarine by the Beatles, even though I like it a lot. I'll spare you of that horror of me singing that song and ruining it for you. But subatomic particles are the smaller particles that make up an atom. And the first one is an electron. An electron is a subatomic particle that possesses a negative electrical charge. It's a minus. Next, protons. Protons are subatomic particles that possess a positive charge, protons. And neutrons are subatomic particles that have no charge associated with them. You should know the three subatomic particles of an atom: the electron, the proton, and the neutron. You should know an electron has a negative charge. The proton has a positive charge, and the neutron has no charge. How many of you have ever seen the cartoon Jimmy Neutron? It's long ago. If they had asked me, I would have called it Jimmy Electron, because that's where the action is in an atom, but they didn't. All right, let's move on. Now, circa about 1900, 1910, there was a lot of research being done in what's an atom. And one important research was done by Dr. Thomson, and that was the cathode ray tube experiments. And you should know it proved that electrons had a negative charge because they didn't know what the charge was. Now, another important experiment was done by Rutherford. And Rutherford's gold foil experiments prove that the center of the atom is very dense. I don't have that here. And we call that the nucleus. And you should know the center of an atom is the nucleus. And one other thing you should know, that the dense nucleus only contains protons and neutrons. So if we look at an atom, in the center, you have the nucleus. All around the nucleus, you have the electrons. And next chapter, I think it is, we'll start going into where are the electrons, because that gets exciting. But now you know I'm a chemist. All right. Now I have it here, but I actually had it on quiz 1, which all of you did real well, just about everybody. Thank you. And that's the atomic number. That tells you by definition the number of protons in the nucleus. Let me go back one more time. Don't forget the nucleus, which was elucidated. By the way, elucidated is a fancy word meaning figured out or explained, had protons and neutrons. Now, the atomic number tells you the number of protons in the nucleus. Now, all atoms of the elements have a net zero charge. So the following is always true. The atomic number equals the number of protons equals the number of electrons. Now, When we look at the periodic table, there are four groups, which are the columns that you should know. And I'll show you a periodic table in a little while. Those are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. And I better be subtle again. And you should be able to give examples of those four. So let's go look at your friendly neighborhood periodic table, which you will be able to download from the assignment area Blackboard for quiz 2, just like you did for quiz 1. Now, the first column, except for hydrogen, are the alkali metals, and mainly lithium, sodium, and potassium. The others are too, but I'd ask you to learn something like cesium or francium or rubidium. Next column, underneath the number 2, are the alkaline earth metals. And the key ones are magnesium and calcium. By the way, Dr. White's likes SR strontium, because when you throw it into a fire, strontium compounds, it makes it red. Dr. White's favorite color is red. Hold on. Red. More red. And there are more up there too. But anyways, the second column is the alkaline earth metals. Now, if we go all the way over to the right, second to last column underneath the number 7, fluorine, chlorine, bromine, iodine, the ones I asked you to learn, are the halogens. How many of you have ever heard of halogen light? And that's because they contain gas of those halogens. And you should know, if I ask, give an example of a halogen, it would be fluorine or chlorine or bromine or iodine. Now, the very last column underneath 8 are called the noble gases. They used to be called the inert gases. Then around 2005, some very inventive Kenneth found a way to make them react. Well, they're no longer inert, so they changed the name. Those are the noble gases. And you should know, like, an example would be one I worked with a lot in grad school was argon. Then there's neon, helium, krypton, xenon, so on. And you should know examples of those noble gases. Now, when we talk about substances, there's an important substance that we call a metal. And a metal is an element that has certain characteristics, physical properties. It has luster. That means you can shine it up like gold. It has thermal conductivity. It conducts heat. If you look at your pots and pans at home, they're made out of metal. Years ago, they tried using glass and people didn't like that. I don't even think they sell them anymore. Metals conduct electricity. Most of the wires in your house are made of copper. They used to be made of aluminum back in the 40s and 50s till they found that caused house fires and that was outlawed. And finally, malleability. Ooh, that's a new word you can impress your friends, neighbors, and loved ones with. What does that mean? You can pound on it and make it very thin. How many of you are familiar with aluminum foil? If you look at the aluminum foil you buy, one side is shiny and the other is not. Thank you. And why is that? When they go to shine it up, it's still too thin. So they put two pieces together, they shine the outside of the two pieces, and that's why the inside is not shiny. See all the neat things you learned in my class? And you should know an example of a metal like aluminum, copper, iron, silver, gold, lead, tin, and zinc are all metals. And I think that's it. I got an extra blank page here. Now, before I leave, let's talk about a cute thing in a metal. I think I have in one of the videos. Years ago, I pulled up to a stoplight, and I'm a license plate reader, and I looked at the license plate in front of me on the car. And the license plate was HIHOAG. I think they were all capital because that's how license plates are. And it took me about 4.5 seconds, and I started laughing, and I said, "That guy's cool." I think it was the gentleman driving. And I'm going to do a generation gap. When I was a boy in grade school, 5, 6, 7, through on, one of the most famous shows on TV for kids was The Lone Ranger with Clayton Moore, not the last Johnny Depp movie. I didn't even watch it. It was so awful, the trailers. But anyways, and it would always start, the Lone Ranger would be on his horse, Silver, and he'd say, "Hi ho, Silver." And that's what this guy's license plate was. And I knew he was the Lone Ranger. Now, I have vanity license plate, but that's a story for another day. And with that, I'm done. I'll be posting this as a video soon, tonight or tomorrow morning, because at 8 o'clock tonight, I'm going to watch the vice presidential debate. Should be interesting. Speaking about debates and vice election coming up, I have never missed an election for major election, never missed a vote, never. I've been voting many decades. Yes, I have. The only time I did was I was for a local school board or something like that election. And I would have gone, but I got a call that I had to go to Germany right before the election. I didn't have an absentee ballot and there wasn't time to get one. So it was a minor election I missed. But other than that, every major election, I've never missed a vote. Brave men and women have died so you can vote. Make sure you register, make sure you vote. It's not that hard. And with that, I'm done. I'll stick around with see if anybody has any last minute questions. You know how I'm going to end. I'm going to say in Yiddish, which means go in hell, gang gesund, and I'll say bye now. Stole that from Granny and the Beverly Hillbillies. Bye.